So now this is brand new stuff. We haven't done this before. Not in grade 10, new stuff. Reflections in the y-axis. Same concept where you've got your base function, parent function, but now we're going to have a reflection or a negative that's acting on the x. We didn't do this last year. So how does this look? So with this example right here, our original function is f of x. It's now going to look like f of the negative inside acting on the x. So if there is an x in, if there's a negative in the bracket that's in front of the x, we're dealing with a horizontal reflection. Horizontal reflection in, oopsie daisies, in y-axis. Okay. So this is our base graph, square root relationship. Square root of 0, 0. Square root of 1, 1. Why am I losing it? Square root of 4 is 2. I just tried something, and I'm going to see if that makes it a little... No, it didn't do anything. Awesome. Okay. So let's go graph that base graph. 0, 0. 1, 1, 4, 2. See how quick I am? Yeah, I know I've told this before, but see how quick I am at graphing the base graph? So much better than up and down. I need you to be that quick. By the end of this course, you need to be able to just, boom, there's the base graph. I got it. I know what I'm doing. Life is good. Okay, so we're going to cheat, and we're going to take the exact, oopsie daisies, I'll do that in a different color. I'll do it in red. We're going to take the exact same x values because we want to see what happens to our base graph if we make the negative value x a negative value. Now, some of you are going to say, well, miss, you can't take the square root of a negative number, and you're absolutely correct. So our base graph, which would be 0, 1, 2, 3, ends up having this negative applied to all the x values. These are what flip over. In the other relationship back here, we had our y values right here was the thing that was doing the flipping. Now we've got the x values that are doing the flipping. So instead, it's still at 0, 0. There's an invariant point. It didn't change when we did the reflection. But now we're going negative 1 up 1, negative 4 up 2, negative 9 up 3. Everyone gets quiet. Even myself as I... Okay, that's better. So we've got a function, whoops, that has a negative under a square root. Guess what? That doesn't exist, but we don't have to worry about that right now. You just have to know that if the negative's inside affecting the x, it is a horizontal reflection through the y-axis. Different language. All right, what's happening here? This relationship has been stopped. Okay, it's the square root of negative x, and that's by itself. And then we've got this negative 5 hanging out at the end. So the negative x, that's our horizontal reflection. And the negative 5, that's outside of the function. This is affecting our vertical. So this is a vert trans down 5. So we're going to take our red graph because the red graph represents the square root of a negative x. And we're going to take this original graph and we're going to drop it down 5. 1, 2, 3, 4, 5. Then we're over 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 9, 1, 2, 3. Okay. I could have used the original points, but I just, because I have those base graphs memorized so much, I just use them all the time. Not trying to show off. A little bit of cleaning up there because this is going on YouTube. Don't give people my link, by the way. This is not what I want people thinking math teachers from Canada are like. Y equals the square root of negative x, and then vertically translated down 5 units. Boom. The graph of f of negative x is the graph of f of x that has been reflected in the y-axis, horizontal reflection. Whoop.